So continuing on with the answers at the bottom of page 8. So the first question was about the bus that asks you to find the average acceleration of a bus that reaches a top speed of 14.2 meters per second from rest. And since there's no direction given, we can really assume that the direction is forward because that's the most likely direction of a bus traveling at that speed. And they gave us a time of 22.8 seconds. So we don't know the acceleration. The initial velocity is 0 because it's at rest. The final velocity is 14.2 meters per second forward, and the time is 22.8 seconds. So when you plug all of that into the equation, you end up with 0.6228 meters per second squared, and I am going to use 3 digits in the answer because we have 3 digits up here, and we will talk about sig figs later on in the class, but for right now, this is a good number to use. So you should end up with 0.623 meters per second squared forward. Please be sure to include the direction because acceleration is a vector. And if you don't include anything, I'm assuming that you don't remember that it's a vector, and then I'm going to take points off. So true or false? Acceleration occurs when a bicycle moves consistently in a straight line. False, because if it's moving consistently, it's not changing its velocity and it's still moving in a straight line, so there's no change in direction. True or false? Acceleration occurs when a raft moves side to side as it floats down the rapids. Well, it moves side to side, so its direction changes, so that's definitely acceleration. And the last one, acceleration occurs when a car pulls into a parking spot. Yeah, well, it is pulling into a parking spot, so it's probably changing direction and most likely changing speed. Hopefully it's slowing down as it's pulling into a parking spot. So that one should be true also. So hopefully you did okay with those, and any of them that you didn't get correct, you understand now. So we're going to move on to the next topic, which is talking about positive and negative acceleration. And this is going to be one of those topics where I'm going to say you really need to kind of focus as I go through this, and you may want to play it back and forth a couple of times. So we're on green, page 9, and I've written most of this out as best as I could, but you really probably need to listen to the explanation. So we don't define positive acceleration as just being rightward or just speeding up, okay? There's reasons for it, and as we get a little bit further into understanding acceleration, it'll kind of make sense. But the table here is what gives it to you, okay? Positive acceleration means you're moving right and speeding up, or you're moving left and slowing down. The negative acceleration are the other options, moving right and slowing down, or moving left and speeding up. So let me kind of dissect this a little bit. So consider, if you move to the right, we normally think of that as being positive. And if you move to the left, we normally think of that as being negative. And typically you would think that speeding up is going to be positive and slowing down is negative. So we're going to combine these like multiplication when you're multiplying positive and negative numbers, okay? Remember, when you're doing that, you've got a positive times a positive and yields a positive number. But a negative times a negative is also going to yield a positive number, okay? Hopefully you guys remember that from your math classes. So if we think about it like that, if we think about moving right and speeding up is basically positive times a positive, when you multiply those together, it ends up with a positive, and that ends up being positive acceleration. If you move left and you slow down, it's a negative times a negative, and that's also going to yield a positive. So that is a positive acceleration. If you have moving right and slowing down, it's essentially a positive times a negative, and that's going to yield a negative. And if you move left and speed up, it's going to be like a negative times a positive, and that's going to yield a negative. Okay. I know this is kind of challenging as I wrote it out here. I did my best to write it out and explain it, but hopefully it somewhat makes sense. If you didn't quite click, go back and rewatch this part again, because trying to memorize this little chart and get it kind of clear in your head, it's very helpful if you recognize that it's very similar to math that you already know. So I want to talk about utilizing some of these positives and negatives and understanding what's going on. And that's going to be the focus of a couple of videos. So we're going to look at green packet page 10. So looking at the information up here at the top, it's really, really important. And that's why I recommend we start out by reading and highlighting it at the top of the page. And then I'm going to do the first couple together. Oh, I wrote them as 1 and 2, but it's really A and B. And then I'm going to have you do the rest as follow-up work. Also, some book problems at the end of chapter 3. So, acceleration like velocity is a vector quantity. To fully describe the acceleration of an object, one must describe the direction of the acceleration vector. A general rule of thumb is that if an object is moving in a straight line and slowing down, then the direction of the acceleration is opposite the direction that's moving. It's kind of like it's holding it back. So if you're pulling up to a stoplight and you're moving north and you're slowing down, it means your acceleration vector is in the opposite direction you're moving. So the acceleration vector is heading south. If the object is speeding up, then the acceleration direction is the same as the direction of the motion. So if you're heading north and you're speeding up, your acceleration vector is in the same direction. Okay, so let's do a couple of these. Read the following statements and indicate the direction up, down, east, west, north, or south of the acceleration vector. So the description of motion. A car is moving eastward along Lake Avenue and increasing its speed from 25 miles per hour to 45 miles per hour. So eastward, it's increasing speed, so the direction of acceleration is also eastward. Letter B. A northbound car skids to a stop to avoid a reckless driver. So it's moving northbound, it's slowing down. So its acceleration vector is southbound. Okay. So for each of these, do the same thing. Read this information about number 10 very carefully. You're going to do the rest of this as follow-up, and then you're going to finish up with a couple of book problems at the end of chapter 3. Those are pretty easy, and I will be back with you on the next video.